is working as a leader in educational sector since 1960 by providing social and technical approach to students. Courses we offer are MTech, BTech, Diploma, Management, NSDC, Agriculture, MLS, HMCT, B Vocational, Fashion Designing, and many more. Our computer science, engineering and IT department works with emergence of new technologies like multi-core processor, mobile and cloud computing. One of the oldest engineering are civil and mechanical engineering, which deals with the design, construction and maintenance of man-made structures and machines. Electronic communication engineering having solid background in devices and circuits, analog and digital machine. Development by providing skill training. Computer application deals with graphic is working as a leader in educational sector since 1960 by providing social, scientific, and technical approach to students. Courses we offer are MTech, BTech, Diploma, Management, NSDC, Agriculture, MLS, HMCT, B Vocational, Fashion Designing, and many more. Our computer science, engineering and IT department works with emergence of new technologies like multi-core processor, mobile and cloud computing. One of the oldest engineering are civil and mechanical engineering, which deals with the design, construction and maintenance of man-made structures and machines. Electronic communication engineering having solid background in devices and circuits, analog and digital machines. On the other hand, NSDC act as catalyst in skill development by providing skill training. Computer application deals with graphic designing and various computing languages, whereas MLS majorly focus on healthcare professional concerned with diagnosis, treatment and prevention of disease. Management and Agriculture Department provides practical approach to help the farming community with the aim to boost agriculture growth in eco-friendly environment. Fashion Designing, Hotel Management, and Applied Science Department are the highly paid industries in today's world. Golden Group introduced bivocational courses which are totally unique and innovative in the entire region, which provides certification in Asia. These courses are specifically for abroad-going students. Golden Group has vibrant training and placement cell. Our placement cell signed MOUs with various national and multinational companies for better placement of students. Golden Group organizes cultural and sports events to provide not only entertainment and enjoyment, but most important to gain and improve skills. We have highly trained and qualified faculty in the entire region, which focus on overall growth of your child. Our motto is to make your dreams come true. Be the part of Golden family today.
A very good morning to all of you. I am Kumenia, serving as Assistant Professor in Agriculture Department. Welcome you all for the today's session. We are having another new webinar today entitled with Nanotechnology, a clear and a green technology. So I would like to welcome everyone who have gathered here with us for the today's session. Nanotechnology is a very new and innovative technology, is a very innovative field in the innovative field of technology. It basically deals with the innovation projects in the field of pharmaceuticals, robotics, and many other fields have great applications in the field of technology. So I would like to welcome and thank everyone for joining us for our today's very valuable and informative session. First of all, I would like to welcome our worthy management, and it's my privilege to address you all, our worthy management, on the behalf of Golden Group of Institute. First of all, I would like to welcome Dr. Mohit Mahajan, Chairman of Golden Group of Institution, and our Managing Director, Engineer Raghav Mahajan, and our prestigious Principal, Dr. Lakhvinder Pal Singh, and our Registrar Engineer, Mohinder Kumar Sharma, and our honorable faculty members and students who have been joining us for the today's session. Welcome you all for the today's live session. So this session has been recorded and the live session for everyone. First of all, I feel so honored to address you all about our institution, Golden Group of Institution. I just want to share a few things about this reputed and prestigious Golden Group of Institution. I would like to thank our worthy management for giving me this opportunity to address on the behalf of the Golden Group of Institute. The Golden Group of Institute established in 1960 and has been set up with a clear vision to pursue the excellence in the field of engineering, management, schooling, and the education. Our basic academic philosophy revolves around the fact that the practical knowledge and the creative combined together can completely change the economic and the political destiny of our nation if shown with the right and pathway. This is why this eminent group is extremely dedicated towards providing the academic excellence and realizing the potential of each and every student. The courses offered by our respective institution, that we are having so many groups and institution and the colleges in this Golden Group of Institution. The Golden College of Engineering and Technology offered many courses such as mechanical engineering, civil engineering, computer science engineering, electronics, and communication engineering. And we are also providing the masters in engineering in the field of computer science, electronics, communication. We are having a Golden Polytechnic colleges also, and Golden Institute of Management and Technology, providing the management courses such as BBA, BCA, BCom Professional, MCom, and BS. We are having BSc courses also, the BSc Non-Medical, the BSc Fashion Designing, BSc Hotel Management, BSc Physics, Physics, and BSc IT. We are having Applied Science Department. We are having BSc in Agriculture Department also. The Golden Group of Institution also have a Golden Group of Education is providing the B.Ed and the Golden Shri Nangli Academic Public School from nursery to +2, academics from nursery to +2. So this is all about our reputed Golden Group of Institute. So now I would like to continue, and I would like to welcome to our today's key spokesperson is Dr. Satbir Singh, is PhD in Electronics and Communication. So although this webinar is the key marker for our institution and is a very valuable and play a very important role in the reputation of our institution. And it also gives us a chance to meet such a brilliant minds. So I would like to welcome you, sir, the Dr. Satbir Singh, for the today's session, who is PhD in Electronics Communication and currently working as a Senior Assistant Professor in the Electronics Technology. He is PhD in Electronics Communication, and he is very well known because of her wonderful administration and the academics. He has so many publications and attended so many conferences related to and is very special. It has a specialization in his field in the nanotechnology, in the nano solar cells, in the nano electronics, and the antenna designs. He has a 19 years of experience in the field of his work. Now he is going to speak on today's webinar, which is entitled as a nanotechnology, and share his views with us and give us so much knowledge. And I'm sure that the student will learn so many things and gain so many knowledge regarding this nanotechnology, which is a very new field to the technology. So I welcome you, sir. Welcome you to this webinar and share your views. And I'm sure your time is worth for this session, and you come to know, everybody come to know so many things regarding this webinar. So at last, I would thank to everyone for hearing me and for having us with you. And without any delay, I would like to continue this session. And over to you, sir. I would like to welcome Satbir Singh and forward this to the Damandeep ma'am, who is the HOD of Electronics and Communication, sir. Over to you, ma'am. She will give the welcome. Welcome to Satbir Singh. Satbir, sir. Thank you so much and have a good day.
Good morning to all. Good morning to all present over here. Myself, Engineer Damandeep Kaur, Head of Electronics Department at Golden College of Engineering and Technology, Gurdaspur. On the behalf of our Vardi management, faculty, and staff members, extends a very warm welcome to our today's resource person, Dr. Satbir Singh, Senior Assistant Professor at GNU Regional Campus, Gurdaspur. It's a matter of immense pleasure to have you as a key speaker for today's webinar, sir. Sir is going to deliver a lecture on an emerging topic, nanotechnology in today's era. Thanks for sparing your valuable time, sir. I also welcome our worthy chairman, Dr. Mohit Mahajan, Managing Director, Engineer Raghav Mahajan, Principal, Dr. Lakhvinder Pal Singh, Registrar, Mr. Mohinder Kumar Sharma, and all faculty and staff members. I also welcome to all guest participants from various institutions. I hope everyone present over here gets the maximum benefit from today's valuable webinar. I again welcome each and every one present over here. Thanks. Over to you, Anku ma'am.
Thank you, ma'am. And now I would like to welcome Satbir, sir, and share your points and continue this webinar. Over to you, sir.
Thank you very much, ma'am. Thank you very much, HOD ma'am. And I am very grateful to the chairman, sir, director, sir, principal, sir, and all the faculty members of computer science and electronics of the Golden Institution, Gurdaspur, for providing me this very much important opportunity on this webinar. So I have some of the experience in this topic, nanotechnology. So this is very vast field in the world nowadays. So today topic of the webinar is nanotechnology, the new era of clean and green technology. So I will present some of the very basic and general slides from my research work that has been finished, completed in my PhD. So actually the work was very complex in the field. So only for the generalization, so I clipped some of the very important slides for the faculty and for the research scholars of your institutions. So basically, we will start from the technology, the nanotechnology. What is it? So from the outline of the presentation, so we have a basic introduction to nanotechnology and nanoparticles, then structure of nanomaterials, applications, implications of this technology, and possible threats of nanotechnology. And the main focused area where I will focus for this webinar is the clean and green energy from the point of view of the nanotechnology. That is the meaningful nature of solar energy cells. So then material used for solar energy cells and world players for the photovoltaic market, because photovoltaic market is related to the solar energy cells. And then different applications of the PV solar cells and nano references. So should I start? Right. So nanotechnology, basics. So what is nanotechnology? What are nanomaterials and what are nanoparticles? So basically, what is nanotechnology? So nanotechnology is the understanding and control of matter at the nanoscale. Nanoscale means so where the measurement has been done in the very, very small range, that is 10 raised to power minus 9 meters. So this is the dimensions between approximately 1 and 100 nanometers. So where unique phenomena enables novel applications. So basically, we start from the nanotechnology. So nanotechnology is the general term for designing and making anything whose use depends on specific structure at the nanoscale. So generally, we take this measurement less than 100 nanometers. So nanomaterials are defined as materials with at least one external dimension. If we have the three-dimensional structure, then out of the three dimensions, at least one external dimension in the size of range from approximately 1 to 100 nanometers. So this is a morphological feature on the nanoscale. So means size less than 100 nanometer. Then we can call this type of the structures may be implemented or may be called in the nanoscale range. So nanomaterials that have the same composition as known as the material in bulk form. Bulk form means the tunable materials too may have different physical and chemical properties. So means there's a difference between the materials at the nanoscale and at the macro scale. Macro scale means where we can observe the size dimension of the materials. So at the macro scale, the physical, chemical, optical properties have been totally different at the nanoscale of the same material. So these may be in the form of particles, tubes, rods, or fibers. So means the nanomaterials can be categorized into different number of particles, number of nanotubes, nanorods, and nanofibers. So this technology involves developing materials, devices within that size and analytical tools. That is the methodology, which
kindly wait for a few minutes. I think there is some technical problem from our speaker.
So I think I am audible to you, all of you. So
Yes, sir, completely audible.
okay, thank you, sir. So this scale is very important in reference to the nanometer scale. So where the materials have been categorized or classified according to their dimensional scale, right? So this antibody to up to virus, 10 raised to power 1 to 10 raised to power 2 nanometers. So this is the actual range of the nano devices where we can synthesize nanomaterials, or we can implement advanced nanomaterials for different type of the implementation in various types of the fields of engineering and basic sciences. So basically, nanoparticles are objects with all three external dimensions at the nanoscale, right? So nanoparticles are of great scientific interest as they are effectively a bridge between the bulk materials and atomic molecular structures. So a bulk material has constant physical properties regardless of its size, but at the nanoscale, size dependent of properties are observed. So it means physical, chemical, electrical, and optical properties of the nanoparticles are very, very important than that of the bulk materials. So then is the structure of nanoparticles or nanomaterials. So the structure of nanomaterials can be characterized according to their actual dimensions at the nanoscale region. So these can be divided into 3 to 4 different classified structures. Number one is the 0-dimensional, second is the 1-dimensional, next is the 2-dimensional, and next one is the 3-dimensional structures. So all types of the quantum dots or nanoparticles are the 0-dimensional 0D nanostructures, right? So nanotubes, nanocables, fibers, nanowires, nanorods are 1-dimensional, means 1D nanostructures. Thin film are under the category of the 2-dimensional 2D nanostructures. And some examples of polymer and colloids shape have classified into the 3-dimensional or 3D nanostructures. So applicable or application area of the nanotechnology. So nanotechnology is a very vast field. So we can implement the properties, the structures, the implementations for different types of the scientific fields or engineering fields, right? So very first is the molecular engineering, optoelectronics, medical sciences, nanosciences, and nanomaterials, right? So application and implications of nanotechnology. So nanotechnology will have applications beyond the chemical biological weapons to include the domains of cyber, robotics, and additive manufacturing. So if we talk about the nowadays implementation of the nanotechnology, it is highly useful in the drug delivery, pharmaceutical, artificial intelligence, machine learning, and space communication based applications. So first, nanotech will lead to rapid improvements in quantum computing, that is the latest field in the computing system, and artificial intelligence, right? So these are the two very vast and growing fields in the world with the help of nanotechnology. Second, the ability to manipulate matter at the near atomic level will yield highly precise and efficient manufacturing process. It has the meaning that we have to synthesize the materials near atomic level scale, means 1 nanometer, so 1 angstrom scale, 10 raised to the power minus 10 meters. So means one step forward than that of the nanometer. So then lightweight, durable, and cheap metal created by the nano manufacturing will have a variety of military uses, especially in the space satellites. Finally, we have the nano manufacturing techniques will augment 3D printing, making complex and scalable designs readily accessible for the future applications. So if we talk about the threats of the nanotechnology, then this could be very dangerous. So there are 3 distinct threats posed by the nanotechnology. The first one is the diffusion of nanotech may increase the likelihood of nano-enabled bioterrorism. So means molecular and biotechnology-based weapons. So nanotechnology is becoming increasingly cheap and user-friendly. Second, nanotechnology will make it easier for the state actors to develop or use advanced chemical bio weapons, right? Third, the potential for new nano-enabled capabilities may accelerate arms races and undermine strategic stability between the world powers like United States and its authoritarian great power competitors like Russia and China. So next is the militaries around the world are already fielding expensive and secretive research and development programs to harness the technology's potential. So these may be the possible threats of the nanotechnology. So from where so next is some of the materials used under the nanoscale range or for the nano materials range. So this is the semiconductor materials for the nanos. So here cadmium selenide, it has an energy band gap of 1.74. This is a direct band gap material, right? So it has the possible application in the nanoparticles, quantum dots. So N-type semiconductor materials used in high efficiency solar cells and in optoelectronic devices. Number two is the cadmium sulfide, CDS. So why I focus on these four materials? Because these are highly used in the nano materials for the synthesis operations. So in the cadmium sulfide, we have 2.42 direct band gap. So this is the energy band gap. So possible applications in the phototransistors, solar cells, quantum dots, also used in the lasers. Next is the zinc oxide. This is very widely used in the nano formations. So zinc oxide is a user-friendly and it has the energy band gap of 3.37, right? So it has a possible applications in the N-type semiconductor materials, nanoparticle fabricating materials, in the light emitting diodes, lasers and solar cells. So last one is the zinc sulfide. So it has 3.54/3.91 direct energy band gap in electron volts. So it has the effective capping agent application in the as a capping agent in the core shell quantum dots used in the solar cells. So core shell quantum dots are very important. So where we can use the efficiency rate of the materials according to the capping, right? So we can cap the unregulated surface geometry of the materials, right? So this is a picture from the nanotechnology. So where it can be used in the electronics for your high-tech electronics or advanced electronics with the help of nanochips. Now, next, that is a very important topic from the nano side. So because I mentioned in the title as the new era of clean and green or renewable energy. So nowadays, it is very important across all the countries of the world how to reduce the global warming, how to change the climate characteristics, right? How to protect the climate. So clean. So we have the different words here. Clean. So clean and green energy, which includes green electricity. That is a clean energy. It has no pollution, no impact on the humans or the living organisms. So this means it is produced with a little to no environmental impact and does not dispense greenhouse gases into the air that contribute to the global warming, the way fossil fuels do, right? Next, varied. Green energy sources include wind, geothermal, hydro, and solar energy. So wind and hydro sources generate energy through the movement of air and water, while geothermal and solar sources generate energy through the heating concept. So all provide reliable energy and protect the environment. So renewable. So green energy sources eliminate the emission of greenhouse gases into the air. So these sources are also renewable energy sources, meaning they are not created from finite materials like fossil fuels, like petroleum products, diesel, petrol, your gaseous products. These are non-renewable materials. The sun is the example of a renewable. So what is the green energy or renewable energy? So stable. Green energy's varied forms means more locations across the planet have the potential to harvest this renewable energy. So this means more energy can be collected right here in India, making the country less dependent on the energy from the foreign countries. So this is the example somewhere located in the Maharashtra. So where we have the wind and solar energy plants. So this is inexpensive energy. So as the demand for green energy continues to grow, the price continues to drop world level, thanks to the economics of the scale. So between the years 2010 and up to 2012, the cost associated with producing energy from wind dropped by 20%, and prices have fallen by more than 80% since 1980. So it means that green energy or your clean energy products are cheaper or inexpensive than that of the older one. So conventional power to the green power. So this is a chart of the conventional power to the renewable energy or to the green power, right? So in the conventional power, we have the coal energy, nuclear energy, oil energy, natural gases. So these are the least beneficial. So then renewable energy, large hydropower, municipal solid waste or waste management, water waste management, more beneficial. And next is the higher level is the green power. So means wind, solar, biomass, geothermal, biogas, and low impact hydropower. So this is the most beneficial category of the green power or energy. So means that if we see conventional power is very costly and it has the impact on the weather, climate. So then the impacts have been reduced by the renewable energy components like large hydropower and the products or the energy products from the solar waste management. So then the third portion is the green power. So this is the most beneficial and protective nature of the environment. So conventional power to the green power. So conventional power, it includes the combustion of fossil fuels like coal, natural gas, and oil, and the nuclear fission of the uranium. So fossil fuels have environmental costs from mining, drilling, or extraction, and emit greenhouse gases and air pollution during the combustion. So although nuclear power generation emits no greenhouse gases during the power generation, it does require mining, extraction, and long-term radioactive waste storage. So this is very dangerous. So green power is subset of the renewable energy and represents those renewable energy resources and technologies, including your nanotechnology, that provide the highest environmental benefit. So we define green power as the electricity produced from solar, wind, geothermal, biogas, eligible biomass, and low impact small hydroelectric sources. Why I mentioned these types of the materials or the environmental benefits? Because these are highly impacted from the nanotechs. So because nanotechnology has been implemented in these areas. So next is the renewable energy. It includes resources that rely on the fuel resources that restore themselves over short periods of the time and do not diminish. Such fuel sources include the sun, wind, moving water, organic plant, and the waste material, eligible biomass, and the earth's heat, that is the geothermal. So potential of the green power and environmental impact. So green power is clean and sustainable, right? So renewable and environmentally friendly. So right, the potential environment impacts associated with solar power means land use and habitat loss, water use and the use of hazardous material in the manufacturing. So these may be dangerous for the environment. So these can vary greatly depending upon the technology, which includes two broad categories. First is the photovoltaic solar cell, and second one is the concentrating solar thermal plants. The scale of the system ranging from small distributed rooftop photovoltaic arrays to large utility scale photovoltaic and concentrating solar thermal plant projects also plays a significant role in the level of the environmental impact. Nowadays, you can see in the cities or in the agriculture, in the villages, we have implementation of the solar cells upon our roof. So for the generation of the clean and green energy. So it estimates for utility scale PV system range from 3.5 to 10 acres per megawatt. So while estimates for concentrating solar thermal plant facilities are between 4 and 16.5 acres per megawatt. So it is meant that the energy generation from the PV solar cells only consume 3.5 to 10 acres of the land. 3.5 to 10 acres per megawatt. So why solar energy? Why we focus on the solar energy? So energy from sun is free, and the sun will continue to shine for billions of years to come. So while the solar energy is inexhaustible and renewable, so its radiance is environment friendly. So the solar power system doesn't emit carbon dioxide, which is environmentally damaging. So in addition, silicon is the raw material in making solar cells, is the second most abundant element in the Earth's crust. So that we have the silicon materials in the formation or in the generation of the nanosolar cells. Since the solar industry has been developing and the technology is maturing, the PV power system are efficient for both commercial and residential use. So if we have the comparison, then the fossil fuels as our main sources of energy are depleting. Our high dependence on the fossil fuel is inevitably going to push up their prices continuously until they are used up. Like now, the petrol and diesel prices are very, very high. So I think it is greater than 100 rupees per liter. So fossil fuels are non-renewable and environmentally damaging. So recent climate change, global warming is in the part of a consequence from the increased carbon dioxide concentration in the atmosphere caused by the industrial smoking, burning fossil fuels, and your transportation system and other types of the industrial applications. So it is essential for us to seek alternative renewable energy sources for guaranteed energy supply and environmental protection. Hence, solar energy is the answer, right? Now, solar energy is the answer, but how to synthesize solar cells? That is the responsibility of your nanotechnology. Now, what is a photovoltaic or a solar cell? So a solar cell or photovoltaic cell is an electrical device. So I am coming to the electronic part that converts the energy of light directly into the electricity by the photovoltaic effect, which is the physical and chemical phenomenon, right? So it is a form of photoelectric cell defined as a device whose electrical characteristics such as current, voltage, or resistance vary when exposed to the light. So I will show you the working principle of the solar cell and its characteristics in the next slides. So individual solar cell devices can be combined to form modules, otherwise known as the solar panels. The common single junction silicon solar cell can produce a maximum open circuit voltage of approximately 0.5 to 0.6 volts. So this is the level of the open circuit voltage. So it can reach up to 1 volt. So solar cells, in addition to producing energy, they can be used as a photodetector. For example, infrared detectors detecting light or other electromagnetic radiations near the visible range or measuring the light intensity. So the visible range, when we see the electromagnetic spectrum of the light, the visible range starting from 400 nanometer to up to its wavelength to up to 600 nanometers, where all the 7 colors have been grown. So basic attributes of the solar cell. So the operation of the PV cell or solar cell requires 3 basic attributes. The first one, the absorption of light, generating either electron hole pairs or excitons. So you know this concept of EH pairs. The separation of charge carriers of the opposite types, right? Whether it is positive or negative. The separate extraction of those carriers to an external circuit. A photoelectrolytic cell or photoelectrochemical cell, on the other hand, refers either to a type of the photovoltaic cell. So modern type of these types of the cells have been known as the dye-sensitized solar cell or the perovskite solar cells. So this is the working of your solar cell or PV cell. So this is the this portion is the layer of the internal part of your solar cell. So these are the anodes, negative and positive, cathode and anode. So some load has been attached to the negative and positive terminals. And this is the negative electrode. This is the non-reflecting shield. So N-type silicon, P-type silicon material and positive electrode. So means where the nanoelectronics has been used inside this cell. This is the non-reflecting sheet or N-type silicon with the P-type silicon. So here we can use the nanopores or nano quantum dots for the nano fabrications, right? So we used a very, very small nano or very, very thin nano layer. So what is the role of this nano layer? So this nano layer will absorb the maximum sunlight or heat radiations from the sun, and then it will convert it into the current or voltage according to your Ohm's law, V is equal to IR. So solar electric devices, commonly referred to as photovoltaics, are able to generate electricity directly from sunlight. So within the semiconductor material present on the solar panels, photons released from the sun cause outer electrons to break free of their atomic bonds. So what will happen then? As electrons are forced in one direction, they create a flow of the electrical charge carriers or electrical current capable of powering electrical devices or sending electricity to the grid. So this is the working principle of the PV cell. This is the solar array that we can install on our home roofs. So this is the solar panel, sunlight, it can absorb P-type silicon. Actually, this type of the array has been manufacturing from silicon material due to its very low cost. But nowadays we have some of the composite materials, gallium arsenide, germanium, indium phosphide, gallium phosphide based materials. So here it shows the electron flow and hole flow. So that is opposite after the heat or after the light irradiations, right? So when there is a flow of electrons inside the electrochemical cell, then if we connect it to the load, means some bulb, then it will be glow. So working principle of the PV. So how it works? So basically photovoltaic effect is the conversion of sunlight energy into the electricity. Semiconducting materials means silicon or germanium in the PV cell are doped to form PN structure as an internal electric field. The P-type positive silicon has the tendency to give up electrons and acquire holes, while the N-type negative silicon accepts electrons. So in this way, one circuit has been completed. When sunlight hits the cell, the photons in the light excite some of the electrons in the semiconductors. So here we can use nanomaterials. Nanomaterials-based semiconductor device like zinc oxide, cadmium sulfide, cadmium selenides to become electron hole, negative positive pairs. So since there is an internal electric field, so these pairs are induced to separate. So as a consequence, the electrons move to the negative electrode while the holes move to the positive electrodes. So one complete circuit has been set up. So a conducting wire connects the negative electrode, the load, and the positive electrodes in the series to form a circuit. As a result, an electric current is generated to supply the external load. So material used for the solar cells. So photovoltaic cells, more commonly known as the solar cells, are found in applications like calculators and satellite panels. So first use almost exclusively in space, photovoltaic cells are now used in more common applications in the daily life. So photovoltaic cells are available in many different shapes and sizes. So when individual photovoltaic cells are joined, they form the photovoltaic modules. So in one module, we can attach more than 50 different photovoltaic cells or more than 50 solar cells. The most commonly used semiconductor material for the construction of photovoltaic cell is the silicon, right? So several forms of the silicons are used for the construction. They are single crystalline, multicrystalline, and amorphous materials, right? So other materials that is highly useful in the photovoltaic cell are the polycrystalline thin film, such as the copper, indium diselenide, cadmium telluride, and gallium arsenide. So these are the complex materials used in the materials. So material used for the solar cells, polycrystalline thin film based solar cells and copper based indium diselenide, CIS based solar cells. So in the polycrystalline thin film based solar cells, numerous thin film technologies are currently being developed to decrease the amount of light absorbing materials required to produce solar cells. So means this could lead to a reduction in the processing cost. However, it could also lead to reduction in the energy conversion efficiency, right? So copper indium diselenide, CIS. Copper indium diselenide has an extremely high absorptivity, right? And so means its absorption coefficient is very high. So this means that 99% of the sunlight illuminated on the CIS will be consumed in the first micrometer of the material. So means it is mostly, it can convert maximum light energy into the electric energy. The addition of a small amount of gallium will improve the efficiency of the photovoltaic device. So this is commonly referred to as the copper indium gallium arsenide diselenide or a CIGS photovoltaic cell. Yes, new materials used for the solar cells. So nowadays we are working upon dye-sensitized solar cells and perovskite materials. So this is the new kind of the solar cell fabrication material, advanced nanomaterials, which are very cheap and very highly efficient for producing the solar to electric generation. So several new solar cell materials have been developed recently. However, most of these are still in their research stages. Apart from the inorganic materials, several polymer-based materials and light-absorbing dyes have been used in the fabrication of the solar cells. So perovskite materials. So perovskite structured materials used in the solar cells are generally hybrid organic and inorganic lead or tin halide materials such as the methyl ammonium lead halide MLH. So these materials can be solution processed, hence enable inexpensive and simple fabrication. So perovskite actually originated from the Russian scientist, Russian origin. The efficiency of the perovskite based solar cells has been steadily increasing and is reported to be more than 20% in the lab currently. So in the silicon or in the polymer based solar cells, when we check the efficiency only up to 7 to 11%. So, but in case of the perovskite based solar cells, the efficiency has been enhanced up to more than 20%. So one of the key advantage of these material is their ability to absorb the sunlight across the entire visible spectrum. So this is a very, very important part of the nanotechnology, how we can absorb the sunlight from the entire visible spectrum. So for the quantum dots, we use these types of the materials like zinc oxide, CDS, CDSC, and PBS. So their band gaps in electron volts can be tuned over a wide range by changing the size of the particles, right? So organic polymer materials, we have the polyethylenediamine, PEI. So I had worked on the PEI in the IIT, Indian Institute of Technology, Ropar. So polyphenylene, vinyl, PPB, and small organic small molecules such as the phthalocyanins, polyscience, and squarines are also used in the solar cells. However, the efficiency of these cells is still low, just a little more than 10%. Hence, they have not been commercialized yet, right?
Yes, sir. मेरे बड़ा time ना उन्होंने presentation.
So next is the dye-sensitized solar cell materials. So this is the Dsscm based solar panels. So this is the another type of the material, solar cell material, based on the ruthenium metal organic dye that can absorb a broad range of the visible region of the sunlight. So an inorganic mesoporous nanoparticle layer, usually titanium dioxide, increases the area of the light absorption. So here TiO2, titanium dioxide. So we had used the nanoparticles of the TiO2, right? So solar cells using these materials can be made using solution processing, making them inexpensive to fabricate in the various applications. So Gretzel et al. First developed the dye-sensitized solar cell in 1991. He's from Switzerland. The DSSC is a liquid type device that involves non-porous titanium oxide, TiO2, as a semiconducting electrode, organic dye sensitizer, and an electrolyte solution containing a redox component. So this is expected to be low-cost solar cell. So the PhD students or MTech students of the institution can search these types of the solar cells for their MTech thesis from the Google. Then the characteristics, IV characteristics also. So this is a very important part of the solar cell. So solar cell current and voltage characteristics. Show the current and voltage IV characteristics as a particular photovoltaic cell. Module of array giving a detailed description of its solar energy, conversion ability, and efficiency. The electrical IV characteristics means more importantly Pmax, the maximum power of a solar cell, determines the device output performance and solar efficiency. The intensity of the solar radiation that hits the cell controls the current I, while the increases in the temperature of the solar cell reduces its voltage V, right? The solar cell produces direct current DC, electricity, and current I times voltage V equals power P. So we can P is equal to V into I, the product of voltage and current. So we can create solar cell IV curves representing the current versus voltage for a photovoltaic device like this. So these are the IV characteristics curves between the voltage and I. So on the x-axis we have the voltage, on the y-axis we have the amperes current. So this is the open circuit voltage. So this curve, so this is the I maximum IV curve. So this is the P maximum. This sharpened curve has been P maximum here, the maximum power point absorbed here. This is the short circuit current density ISC. So this is the open circuit voltage VOC. So here the area has been covered from the VMP into IMP. So means you can calculate the current and voltage coordinates from this curve. So the important characteristics of solar cell or array. So VOC open circuit voltage, ISC the short circuit current, MPP the maximum power points. So in short, so open circuit voltage with the solar cell open circuit that is not connected to any load, the current will be at its minimum 0 and the voltage through the cell is at the maximum. So known as the solar cells open circuit voltage or VOC. So this value depends on the number of PV panels connected together in the series. ISC, I short circuit. At the other extreme, when the solar cell is short circuited, that is the positive and negative leads connected together. The voltage across the cell is at its minimum 0, but the current flowing out of the cell reaches its maximum, known as the solar cell short circuit current, ISC. Maximum point, maximum power point. So this relates to the point where the power supplied by the cell or array that is connected to the load, batteries, inverters, at its maximum value. So maximum value of the power is the product of the V maximum into the I maximum, right? Then is the fill factor. So this is very important factor regarding your solar cell design, right? The fill factor is the relationship between the maximum power that the cell or array can actually provide under normal operating conditions and the product of the open circuit voltage times the short circuit current. Means this is the product of VOC into ISC. The fill factor value typically between 0.7 to 8. So when it is closer to the 1 unity, the more power the array can provide. Percentage efficiency of the cell. The efficiency of a photovoltaic cell or array is the ratio between the maximum electrical power that the array can produce compared to the amount of solar radiation or radiance hitting the array. The efficiency of a typical solar cell is normally around very low, 10 to 12%, depending upon the type of the cells, whether we used monocrystalline materials, polycrystalline materials, or thin films. So this is the timeline of the solar cells. So starting from 1839. So world player of the PV market, China is the world's largest market for both photovoltaics and solar energy. Okay. So since after 217, China was the first country to pass 100 gigawatt of the cumulative installed PV capacity. And by the end of 2018, it had 174 gigawatt of the cumulative installed solar capacity. So the goal for 2050 of the world level goal is to reach 1300 gigawatt of the solar capacity. So if this goal is to be reached, it would be the source with the largest installed capacity in the China, right? So in January 2016, the President of France, Francois Hollande, and the Prime Minister of India, Shri Narendra Modi, laid the foundation stone for the headquarters of the International Solar Alliance, ISA, in Gavalpahari, Gurgaon, India. So the ISA will focus on promoting and developing solar energy and solar products for countries, lying wholly or partially between the Tropic of Cancer and the Tropic of the Capricorn. So India is situated in this line. So the alliance of over 120 countries was announced at the Paris COP21 Climate Summit. So one of the hopes of the ISA is that wider deployment will reduce production and development costs, and thus facilitates increased deployment of the solar technologies, including in the poor and remote regions. Similarly, Australia, Canada, USA, all are focused on the sustainable renewable energy systems. So scenario of the Indian solar system, Indian solar PV market. So solar power in India is a fast developing industry. The country's solar installed capacity reached 31.696 gigawatt as of 31st October 2019. So India has the lowest capital cost per megawatt globally to install the solar power plants, because in India, the total sunshine days more than 300 in the North India and in the Middle India, right? So the Indian government had an initial target of 20 gigawatt capacity up to 2022, which was achieved 4 years ahead of the schedule, right? So India has established nearly 42 solar parks to make land available to the promotions or promoters of the solar plants. So the country added 3 gigawatt of the solar capacity in the recent years, 2015 to 16, 5 gigawatt in 2016 to 17, and over 10 gigawatt in 2017 to 18. So means with the average current price of the solar electricity dropping to 18% below the average price of its coal-fired counterpart. So by the end of September 2019 or the starting of the 2020, India has installed more than 82,580 megawatt of the renewable energy capacity projects, with around 31,150 megawatt of the capacity under the various stages of the installations. So nowadays, the rooftop solar power accounts for 2.1 gigawatt, that is, which is 70% is industrial or commercial. So in addition to its large-scale grid-connected solar photovoltaic PV initiative, India is developing off-grid solar power for local energy needs, right? So solar electricity generation recorded nearly 3.4% of the total utility electricity generation in January 2019. So means India is growing very fastly in the PV market. So this is the northern Indian region installed solar power capacity in the northern Indian region. So here Rajasthan, Punjab, Uttar Pradesh, up to 15 to 2019, right? So means Rajasthan is producing very high. It is approaching to 3,300 megawatts. Then Punjab, then Uttar Pradesh, Uttarakhand, Haryana, Delhi, J&K, Chandigarh, and Himachal Pradesh. So these are the data available from the Ministry of New and Renewable Energy, MNRE, Government of India. So this is the applicable area of the solar cells. So domestically, we can use nanotechnology based solar cells in the form of rooftop solar cells. So these are the references. So where we can, or you can find out the materials for your search work. So then up to 2020, I have some of the publications in this core area of the nanotechnology. So means I have published one book on the nanotechnology. So total I have publications 43 in the reputed journals and 25 conference, national and international repute. So published various articles in different newspapers of North India, published various scientific articles in Joina Journal, Ministry of Information and Broadcasting, Government of India, and various other journals of Government of Punjab, and various other journals, Punjabi, Hindi or English in the Canada or other countries. So I have some of the professional memberships from different countries in the nanotechnology. So currently presently I am the member of the United States American Association for the Advancement of the Sciences, AAAS. And second, since 2018, I am a member of the International Association of the Advanced Materials, Nanomaterials, Sweden, and other Optical Society of India and Optical Society of America based membership for the professional growth and research academics. So thank you very much for all of you. So I am very thankful to the director sir, principal sir, faculty members, HOD electronics, HOD computer science, and other faculty members, research students of your institution for a pleasant time or for understanding the concepts, basics of nanomaterials, then its implementation, application area regarding the growth of the research work. So I think, so any questioning from the audience, from the students, from the faculty, so you're most welcome.
Yeah, thank you very much, sir. Thank you for enlightening some of the beautiful and recent electronics background or the engineering background or any kind of technical background who seek to open up their career in the field of nanotechnology.
Yes, sir.
And thank you for enlightening your tremendous. Yes, sir.
Actually, the students of BTech, MTech, and PhD students can focus on this hot area of the electronics, that is the nanoelectronics, because it is a not tough area, so it is understandable area. So for academics and research work, they can focus, they can search on different types of the nano applications because it is highly useful in robotics, in civil engineering, in mechanical engineering, in computer engineering, even in the nanoelectronics, in the electronics engineering. So we can participate in the conferences related to the nanotechnology in India or across the world, level seminars, webinars, or we can launch or inaugurate these types of the courses in our universities or colleges for the betterment of future of the students. So thank you very much, sir.
Yeah, exactly, sir. That is what I was talking.
Yes, sir. Some voice problems here, actually.
Wrapping up our session now. If anybody will be having any query or message, then we shall be contacting you either through mail or some other purpose, some other medium. Thank you so much, sir, for sparing your valuable time and sharing such valuable thoughts about the recent trends going in the nanotechnology. And we shall hope to conduct some more webinars and informative sessions from your side.
Thank you so much.
It will be kind thing from you. Okay, thank you, sir. Thank you so much for having you. We are wrapping up the session. Thank you, sir. Thank you, sir.